Chapter 3 Matter, Energy, and the Universe. Section 3.5 Energy Transfer on our Planet. Let's return to talking about three processes that move energy about the Earth. And these processes are conduction, convection, and radiation. So let's define what these processes are. Conduction is energy transferred in a substance directly from molecule to molecule. The molecules must come in contact with each other, and they must transfer that kinetic heat energy that exists in one molecule to another molecule. So this conduction occurs only if there is a temperature gradient, and conduction moves heat energy from where it's greater to where it's less. An example of conduction is when you're cooking, let's say, pasta. You're boiling some water. So your burner on your stove is creating the heat energy. That heat energy is being transferred from that surface to the molecules in the metal, and they transfer across the metal surface to then transferring by conduction that heat energy to a thin layer of water at the bottom of the pot. Convection is the transfer of energy by vertical mass motions of a gaseous or liquid medium. Convection does not occur in solids. If convection is occurring horizontally, then a different term is used, and that is advection. So let's get back to that pot of boiling water. So as I said, we've got heat energy being transferred from the burner to the metal. It goes through the layer of metal, and that heat energy is then at the surface that meets the water. The water heats up, and then the water starts moving by mass motions. So what's really warm, a warm mass of water near the bottom of the pot starts to flow upwards. It makes a mass motion in the vertical. That's convection. Convection is very active in the Earth's atmosphere. Convection also occurs in the Earth's oceans and other water bodies. And often you may see convection in the atmosphere on a hot summer day, and you're looking across, let's say, some black soil or black pavement, and you see it looks like there's waves moving through the atmosphere. That's convection. That's masses of air moving upward. Now, please note that when warm air moves up, that creates a vacuum, and that pulls cold air down. Radiation is a transfer of energy by the creation of electromagnetic waves. So atoms and molecules have the ability to radiate, and they produce electromagnetic waves. In many cases, we can't see these electromagnetic waves. They're invisible, and they move away from the molecules, the mass, and as the propagation occurs, heat energy is removed from that mass, and it starts to cool down. Radiation can move energy through space without the aid of material medium. Conduction and convection require either a gas or a liquid for them to occur in. Radiation doesn't need that. In terms of what powers the Earth's systems, it's powered by solar radiation. So the sun out there is of high temperature. It's emitting radiation into space, and our planet intercepts a portion of that radiation, and then that radiation runs the biosphere, the atmosphere, processes in the lithosphere, and the hydrosphere. Now, life has the ability to capture energy, and this is done by plant organisms that can perform photosynthesis. And through photosynthesis, these organisms can capture the energy that's in radiation from the sun, and then with the addition of carbon dioxide and water, they can create basic glucose molecules, and these glucose molecules are organic energy in its simplest form. So let's take a closer look at photosynthesis, and then it's also its reverse process called respiration. And respiration is done by plants and animals. Photosynthesis only by photosynthetic organisms like plants. So these processes that we're talking about move energy through living systems, through ecosystems. So how does photosynthesis work? So plants within their cells have these chloroplasts. These chloroplasts have the ability to absorb solar radiation, and then with the addition of carbon dioxide and water and this light energy, they can form glucose molecules. The chemical reaction can be described by the equation shown in this slide. So the reaction requires 6 carbon dioxide molecules plus 6 water molecules plus light energy, and in these chloroplasts they then produce glucose, which is that C6H12O6. So that means 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen forms glucose. And the other byproduct of photosynthesis is oxygen, and 6 molecules of oxygen are produced. So why do they use 6 carbon dioxide, 6 hydrogen, and 6 oxygen to balance the equation? That's why the value 6 is shown there. So in the simplest sense, here's photosynthesis: plant receiving sunlight. It takes in carbon dioxide, water with its roots, and it produces glucose, and it builds its tissues. Some of that glucose in the tissues can be passed on to heterotroph organisms. So a herbivore could eat that plant, and then that herbivore could be eaten by a carnivore. The other byproduct of photosynthesis, besides glucose, is oxygen. So let's just repeat this. Photosynthesis produces the carbohydrate glucose, a simple sugar, and oxygen, and the oxygen is released into the atmosphere. Glucose is produced by chemically combining carbon dioxide and water with sunlight. Glucose within the plant, glucose can later be converted into more complex organic molecules, more complex sugars, or starch for storage, or it can be combined to produce specialized carbohydrates like cellulose, or other nutrients can be added, and it can produce proteins and nucleic acids. So here, glucose can be combined with other nutrients such as nitrogen, phosphorus, and sulfur, and build complex molecules such as proteins and nucleic acids. Cellular respiration is the opposite of photosynthesis. So if you look, that equation has been reversed. Cellular respiration occurs in all organisms, plant and animal. The chemical reaction is just the opposite. So a simple glucose molecule plus oxygen is broken down in something called a mitochondria within the cells, and this produces energy that can be used for metabolism and the byproducts of carbon dioxide and water. So here we have cellular respiration represented in the simple diagram, right? The plant takes in oxygen, it takes the glucose within its tissues, breaks them down, and produces energy, carbon dioxide, and water. So respiration, as I said, occurs in both plants and animals. In most organisms, cellular respiration releases the energy required for all metabolic processes. Products of respiration include energy that is used in the metabolism of the organism, carbon dioxide, and water.